On the internet you find in math forums, on YouTube and various other places such as Google AI Overview, some little bit misleading information about the geometrical basis for the volume formula for the pyramid shape. We'll explain the mistake. Essentially the error consists of a generalization without justification. It should not be necessary to remind that it is worth always to look out for flawed reasoning, whether you are a student or a working person. What we are talking about is specifically when an illustration or a claimed proof yields a result which is only applicable for a particular case, and the evidence of generality is in fact lacking. Firstly, in this instructional video, it is essential to advise that the best way of proving the formula V equals L squared times H divided by 3 is by use of integration. Calculus is an enormously powerful toolbox and of course has a simple answer to why the formula is true. But let's try to hold the thought today that surely the volume can be demonstrated without calculus knowledge. After all, to many of us, integration is an all-forgotten realm of mathematics. The viewer may want to note that in this video, which approaches the symmetric pyramid systematically, we come across observations which are normally referred to algebraically as dead ends, an equation which may shed light on something, but is not bringing us any further to a quantitative solution. Now the various sources online are making a point of a few proofs which are not valid, in fact only applicable to 45-degree pyramids. But say, the Egyptian pyramids are not 45 degrees, though not always very far from this angle. In fact, the slope of the Cheops pyramid is about 52 degrees. You may want to spend a bit of time on what we will here show a semi-graphical proof for the volume formula, which is dealing with symmetric pyramids of square base and arbitrary height. The illustrations in this video are created with a relatively cheap generic 3D drawing program called AC3D. You can refer to credits at the end of the video. The pyramid has base length L and height H. We now display the box that encapsulates the pyramid, a box with volume L squared times H. Now we will try to deduct information about the pyramid volume by dissection of the boxed volume. The first attempt will involve drawing up the 4 right prisms which encapsulate the pyramid in its box. In this view, we see one prism displayed in its position next to the pyramid. If we consider 4 such prisms, one on each side, these prisms overlap each other, and we can illustrate the overlap volumes with yellow wedges. These 4 yellow wedges can be held together and they shape a pyramid of equal shape as the purple pyramid. If we do basic volume summation, we see that the following equation arises. The problem with this equation is that the unknown volume function p is being cancelled out, such that we are absolutely nothing closer to defining p. However, we shall use the corner piece information in our next way of breaking down the volume. Consider the volume which is not in the pyramid and not in the corner prisms. That volume is here illustrated in green color. We can write a new formula for the box volume. We are left with b equals 2p plus r. Let's now inspect the volume of r algebraically. By use of former knowledge on triangles, we arrive at the following expression for the total of 4 green wedges. P is again a pyramid volume and we refer to a pyramid split in half. We can insert this formula for r in the previous formula. We see that also in this case, unfortunately it's the case that the volume function p cancels out, and we are not closer to an expression for p. However, from the box volume equation b equals 2p plus r, we know something about the makeup of the pyramid volume. Let's write all the information we have. The box volume, so L squared times H equals 2p function of L and H plus r function of L and H. We now revert to the requirement of proportionality to argue that p and r must be multiples of L squared H. Specifically we have thus we can write We see that L squared time H is removed by division and we have a formula which relates N to K. We also know that we can disregard K equals 0 since the wedges of volume R have a non-zero volume. In order to get a closure relation, we will inspect a special case of pyramid. We have for a centered pyramid of height equal to half the side, that due to 6 equal pyramids exactly filling a cube. This is the main so-called intuitive proof which keeps being referred to at online sources, but it is only applicable for that special case. We are going to properly use this known factor as closure information. Instead of performing an odd algebraic exercise, we shall here do an insertion for a selected pyramid case. The side length is here 10 meters and the height is 5 meters. This n is thus universally valid, i.e. we have In order to summarize, we approached systematically, without calculus techniques, the symmetric square base pyramid of arbitrary height. We succeeded, thanks to volumetric equivalence, in pinning down the form of the volume function, and determined the relevant general multiplier by considering a special case, namely the 45-degree centered pyramid. We then have that little bit of added confidence maybe, if we were to calculate the weight of an Egyptian pyramid. This weight is given by volume times the rock's density. Still, the result would become more accurate if you deduct the volume of grave rooms and tunnels.